Okay, so welcome back. The purpose of this video is to explain to you the derivative using the definition of the derivative. Later on, we are going to be talking about tables and graphs, but for this video, we are going to evaluate the derivative using the definition. So let's get started. Some of these notes are going to feel a little bit of review, and that's okay because that allows us to kind of go back and give you a little bit of background. So first of all, what is the definition of the derivative? Well, we've defined that as a limit as h approaches 0 of f of x plus h minus f of x all over h. And remember, we got this formula by using the slope formula and subtracting two y values, subtracting two x values, that's simplified to h. So really, this is just that formula y2 minus y1 over x2 minus x1. And so what does this mean? Well, it's the derivative. It's also the slope of the tangent line. And it is also instantaneous rate of change. Okay, so we talked about notation. If the original function's notation were f of x, then its derivative would be f prime of x. And its second derivative, and again, you can take many derivatives, but we're going to focus on the first two for this video. You would put a second apostrophe, and you would pronounce this f double prime. Now, if we call the function y, instead of f of x, you could use y prime, or you could use dy dx. And this just means the derivative of y in terms of x. For the second derivative, you can use two apostrophes, or you can use this notation, which seems like it means the derivative squared, but it's not the derivative squared. It is the second derivative. That's what it stands for. One more thing that I want to tell you about derivatives is sometimes instead of seeing this notation, sometimes you're going to see sort of a command notation. And I want to make sure you understand what that means. Let's say that f of x equaled, let's say x squared plus 1. So if you see f prime of x equals, or y prime equals, or dy dx equals, then you kind of interpret that to mean take the derivative of what they told you was the original function. Sometimes mathematicians won't write this down. They won't write the function and then ask you for the derivative. Sometimes they're just going to straight up do this. They're going to put a d dx, and then they're going to put the function in parentheses. And the difference between this notation and this one is the derivative. But this is supposed to be a command. Take the derivative of everything you see inside. And so it's really asking you for the same thing as dy dx, but instead of writing this is the function, now find dy dx or f prime of x, I'm just going to write d dx with the function inside and save myself a little bit of typing, and you understand that that means find the derivative. All right, so the next thing I want to talk about is how do you evaluate this formula that we talked about? Well, keep the formula in mind. The definition is the limit as h approaches 0 of f of x plus h minus f of x over h. And what we're going to vary, or what's going to change, is what function you are given. Excuse me. Here in this example, we are given f of x equals x squared plus 3x. Okay, that's cool. So what do we do? Well, we're going to take the limit as h goes to 0. There's no h right now in this function, but we are going to insert x plus h into f of x for the first piece. So we're going to take this x, and wherever we see x, we are going to replace that x with x plus h. In this function, we have two x's, two places where x is going to get replaced, so make sure you apply it to both places. Oftentimes, students will replace one variable and forget that there's another one that they need to plug it into. So we'll start with x plus h squared, and then we'll do plus 3 x plus h. And I know you see two terms here, but this is really just the first piece, f of x plus h. We are now going to subtract f of x, which is the second piece, and f of x is just the original function. It does have two terms, so please use parentheses so that you remember you are subtracting every term in that function, not just the x squared. That's important. And it's always going to happen because the formula always has a minus. So if you have more than one term, you need to make sure you put parentheses, or you remember to distribute the negative as you work. divided by h. So now this is just simplification. We cannot plug h equal to 0 right now, because if we do, you're going to notice that we get 0 over 0. So that would mean do more math. So instead, what we're going to do is expand this, distribute the 3, distribute the negative, and we're going to get a series of cancellations. It's going to take a little bit of time. So I'm going to go ahead and you can pause the video, work it out. I'm going to pause the video, work it out myself, and then we can compare. So I've worked out the algebra here, and I got a lot of cancellations. Ended up with 2xh plus h squared plus 3h over h. Everything has an h, so I factored out an h, which reduced that h on the denominator. That's exactly what I wanted to happen. I still have an h left over, but I'm not nervous about that because it's not in the denominator. And now I get ready to apply the limit. So the limit as h approaches 0, you're going to see that this h then goes to 0. That's fine. And we are left with simply 2x plus h. If you're wondering about the x is not h, so it didn't turn into anything. It stayed as it is. And this here, I kind of had to use my space wisely, would be the derivative of f of x. And so that's how you apply the formula. Okay? So the next question, and you're going to be practicing this a little bit more, but this is basically how it works. You plug in your x plus h, and then you got to find a way to simplify. So in object, we're going to move on to the IRC example. An object dropped from a building falls y equals 16 t squared feet after t seconds. Find the object speed at t equals 3 seconds. So one way to do this would be the old way. Pick 2 points, t equals 3 and maybe t equals 3.001, and then approximate. Well, that's the old way. The new way is to use derivatives, because the derivative is the instantaneous rate of change of any quantity. In this case, we're going to take the instantaneous rate of change of y equals 16t squared. And we're going to use our formula. We're going to take the limit as h approaches 0 of f of x plus h minus f of x divided by h. And so what's going to happen is that I'm going to have to apply this formula to this function. So what we'll get here for the derivative will be the limit as h approaches 0. And instead of x, we really have t. So that'll be 16 times t plus h squared minus the function. We only have one term, 16t squared, divided by h. Okay, and I'll give you a moment to work that out. Okay, so these are the 3 definitions that I want you to make sure you have in your notes. Secant line, a line that passes through 2 points on f of x. A tangent line, a line that touches f of x at 1 point only. And I kind of want to explain this a little bit more. So let's say that we had a tangent line that went through this function here. Try to draw a tangent line. It touches a function at 1 point, but actually it touches a function again. So what I want you to note here is that this function, this tangent line, is tangent to the function here. And it is not tangent over here. It's tangent here. And in this neighborhood, in this location, it touches it only once. So that's just to clarify. Some people get confused because they think it touches 2 times. It does. But the tangent line is really happening here. While it's tangent at this point, it is not at that other point. All right, so what is a normal line? This is a little bit new. If you have a normal line, that is just a line that is perpendicular to the tangent line. So let's draw a function here. Let's say you have a tangent line, just like I drew before. Okay, we talked about being tangent here. A normal line is going to be a line that is perpendicular to that one. So it goes right through the point of tangency, and it makes a 90-degree angle. So if you're thinking, wait, so what's the deal with that? Well, whatever the slope of the red line is, the tangent line, your orange line, the normal line, is going to be the opposite reciprocal of that. Okay? And so what we're going to do now is kind of work out an example to show you how you would work with these 3 scenarios. Okay, so here are the instructions. Write the equation of each line using f of x equals x squared plus 3x. If you notice, this is the same function that we already did the derivative previously. So we're going to be able to use that. So the first one, we're going to write the equation of the tangent line. And we're going to say that we want the tangent line, the secant line. We'll do the secant line through -2 and 0. So the 2 points, x equals -2 and 0, that's what we want the secant line. Well, if we're going to write the equation of a secant line, we need to first find the slope, which means we need to have 2 points. And right now, we have only the x-coordinate of one point and the x-coordinate of the second point, which means we have to find the y's. Those y values are going to come from the original function. So in other words, we need to evaluate an f of negative 2 into the original function, which is going to give us negative 2, I believe. So we can fill that in. That's just plugging in here to x squared plus 3x. And now we're going to find f of 0. That's pretty easy. Again, if you plug in 0 into the function, you get 0. So here we are. Okay. Now, what we're going to do next, and this is just a coincidence that the x and the y came out to be the same. That's not always the case. So we have our 2 points that we need. And so now what we're going to do is find the slope. So the slope of this line is going to be negative 2 minus 0. This is just the y2 minus y1. And that's going to give us a 1. So the slope of this secant line would be 1. And then we can use any point that we want to write the equation in point-slope form. If this is a y-intercept, so we could use that as well. But really, you could do anything here, any of the two. So minus negative 2 equals negative 1 times x minus negative 2. And as I told you before, you can totally just leave it like that, or you can solve for y. And that's the secant line. So moving on to the tangent line. In the tangent line, we're also going to need to know the slope of the line, but we can't use slope formula because we don't have 2 points. In this case, they're going to tell us to find tangent line at x equals negative 2. Well, I only have 1 point, and even if I find the y value, which I already know, f of negative 2 is negative 2, so that gives us a point negative 2, negative 2. Even if I have that point, I don't have a slope, and I can't find the slope with slope formula. So that is when we're going to use the derivative. And if you remember from the previous notes, we found the derivative for that function to be 2x plus 3. So we already know that. We already worked it out using the definition of the derivative. So we're just going to come back here and say, all right, if the derivative of x is 2x, let me erase that, 2x plus 3. Okay. If the derivative is 2x plus 3, that's fine. Then we're going to find the derivative at negative 2. So f prime of negative 2 is going to be 2 times negative 2 plus 3. So again, we're trying to find the slope of the tangent line at negative 2. So f prime of negative 2 is going to be negative 4 plus 3, which is negative 1. And that, negative 1, that is our slope. So now we will run the point-slope form using our y, our x, and our new slope. So y minus negative 2 equals negative 1 times x minus negative 2. And again, you don't have to solve for y. You can just leave it like that. And that's the slope, that's the equation of the tangent line. Now, the last one is the normal line. And the normal line is perpendicular to the tangent line. Since we know the slope of the tangent line, and we're going to do normal line, let's go ahead and do the normal line at x equals negative 2. Since we know the slope of the tangent line is negative 1 at negative 2, we also know the point is negative 2, negative 2. We're going to find the slope of this line. The slope of the tangent line was negative 1. The slope of our line is going to be the opposite reciprocal. So the reciprocal of 1 is just 1, and the opposite of negative is positive. So our slope is 1. Once you have that information, you just plug in the formula. Y minus negative 2 equals 1. So the only thing that's going to change between this and the tangent line is going to be that the slope is the opposite reciprocal. Everything else stays the same. Okay? So hopefully this video helps you understand how to evaluate the derivative. And then here's how you write a secant, here's how you write a tangent, and here's how you write a normal. All right, see you guys tomorrow.